So in today's video, we were going to be learning how to calculate kinetic energy and potential energy using mathematical formulas. So kinetic energy, again, is the energy of motion. So when you see a word problem of kinetic potential energy and it's talking about a moving object, you know to use a kinetic energy formula. Below you see the kinetic energy formula. It is Ke equals 0.5 mv squared, where m is for mass, always in kilograms. You may have to convert from grams into kilograms. Mass is always in kilograms. V is always in velocity, which should be written in meters per second squared. Ke stands for kinetic energy, which is measured in something called joules. A joule is the unit used to measure energy. The other type of potential energy that we'll be discussing, the one type of potential energy we're going to be discussing is gravitational potential energy. It's the only type we'll be using mathematic formulas for. This is stored energy before an object falls. Gravitational potential energy is shortened as GPE. This is the formula to calculate GPE. GPE equals mgh, where m once again stands for mass in kilograms. G stands for gravity, which on Earth is always measured in 9.8 meters per second squared. Don't get confused by the squared, it just stands for the unit. When plugging in gravity, you only plug in 9.8. Don't square it, just put in the 9.8. But you always put in 9.8 as long as our word problem is taking place on Earth. And finally, H stands for height, which is measured in meters. So let's try one of these word problems together. So we're given that the kinetic energy of a 625 kilogram roller coaster car is moving with a speed of 18.3 meters per second. So it's asking us to calculate the kinetic energy of this object. So I would just start out by writing out the kinetic energy formula, which is Ke is equal to 0.5 mv squared. So now it's more or less just plugging in the numbers. So we can keep the 0.5. The mass we know is 625, and we can multiply that by 18.3. And make sure you square the 18.3. And if you multiply across, I would multiply 0.5 times 625 first, then multiply by 18.3 squared, giving us an answer of Ke is equal to 104,653. And you can just round up, and that's in joules. Don't forget to put your unit. So this is an example where it's telling us to calculate the potential energy. So once again, I would refer straight to the formula. So let's use our formula here. So let's write the formula for PE. PE is equal to mgh. So our mass is 75. Our gravity, remember, is always 9.8. Don't square the 9.8. And then finally, it's 300 meters. It's 300 meters. And once again, we just multiply across. So using your calculator, and again, you know you always use the calculator in my classroom, you find out that PE is equal to 220,500 joules. So here we have a word problem where it's telling us Missy Dyewater, the former platform diver for the Ringling Brothers Circus, had energy of 1,200 joules just prior to hitting the bucket of water. If Missy's mass is 40 kilograms, then what is her speed? Uh-oh, here's a catch. It's not asking us whether to solve for kinetic potential energy. So your clue here is that it's kinetic energy because she's moving. She had 1,200 joules just prior to hitting the bucket of water, meaning she must have been moving. So we know right away to use our kinetic energy formula. Now, they gave us Ke, which is 1,200. She gave us Ke, and it also gave us the mass. Now it's asking us to find the speed. So let's do Ke equals, we have our 0.5, and now we have to put in 40 for the mass. And finally, we're going to put in v squared because we don't know her velocity, so we'll keep v as a variable. So next thing you should do is multiply the 0.5 by 40, so that's 20. We can keep the v squared equals the 1200. Now you can divide both sides by 20 in the simple algebra formula, isolating v squared, leaving the 1200 now at 600. If you know from math class, if you have a variable squared, you take the square root of both. So let's take the square root of 600, square root of v squared, giving us v equals 24.5 meters per second. It's a little bit scrunched up there, but that's meters per second. Don't forget your units. So now we have a cart loaded with brick and pulled at a constant speed along an inclined plane to the top of a mountain. If the mass of the loaded cart is 3 kilograms and the cart has 13,023 joules of energy at the top of the mountain, how high is the mountain? So some of you may already be thinking, well, this cart is at the top of the mountain, and if you remember the last video, when something reaches the peak and it's not moving, we need to be using potential energy. So let's use our potential energy formula. So for this one, we know the potential energy is 13,023 joules. Let's set that equal to 3 because 3 is the kilogram, so here's our mass, 3.0, and we can multiply that by, if we remember, 9.8 is our gravity. You always have that 9.8 to count on. And finally, our variable is h because it's asking us how high is this mountain. So I would, very first thing, multiply 3 times 9.8, giving you 29.4 h is equal to that 1323. And then I would divide both sides by 29.4, giving us h is equal to, so now we have h down here, is set equal to 443.0 meters, because height is always in meters.